I think. Yes, since you made me co-host. Okay. Yay, okay. So I'm going ahead and recording, so that's fine. All right, so people are entering the waiting room. View. Admit all. Okay. So we're just waiting for people to join here. Last minute kind of stuff. Sorry about that confusion due to the power outage, which apparently didn't last too long. Oh, good. We're at 40 participants, so that should be perfectly fine at this point. Okay, well, more convenient because that means I just have to do this spiel once as opposed to twice. So, good morning, everyone. I am Professor Rosen. Let me go ahead and mute everybody else. So let's see. So I'm your professor for 2168 data structures. I've been teaching this class for a while, since I joined Temple at 2016, and I was teaching this course back when I was a graduate student. So I've been teaching this course or some variation of this course for since about 2012. So I've got this course pretty much down to a really good system. First and foremost, if you aren't aware of this fact, this is a flipped course. So that means that there are videos for you to watch prior to coming to class. Now, of course, how are you supposed to watch videos before you knew this fact? Well, fortunately, this first week and part of the second week is pure review, which is to say that first week one, we're just focusing on object-oriented programming. I know we had a longer than usual break, so this is probably a very good first assignment for that. Secondly, the second week goes over array lists, but rather than learning just how to use array lists like you might have in 1068, we're going to be learning about how they're built internally. So we'll be building an array list for objects from scratch. And so that should give you a much deeper understanding of the kinds of manipulations you can do with them. Now, that being said, if you haven't learned about array lists yet because you're coming in as a transfer student or from another institution, that's perfectly fine. I don't assume that you know what an array list is from the very beginning. Or you may not remember it. So I assume you're coming in with no base knowledge there. But for the most part, you can go to the modules page over here and you will find all your assignments. There's some unpublished quizzes that we'll have. Quizzes, by the way, as I'll explain on Wednesday, are kind of a do at your own pace kind of deal. You get, as long as you do them by the due date, I don't really it's perfectly fine. As far as when you take them when you're ready. But basically each of these is broken into two parts. Well, three parts. You've got your videos, you've got your quizzes, and then you've got whatever homework is associated with that week or 2 weeks. So for instance, when we get to recursion, that typically takes 2 weeks. So it's fairly well organized because, I spent a lot of time organizing it. Your first exam will be around, I would say, week 5 or 6 of the semester. Just depends on how things go. But typically it happens around week 6. And then after your second exam is on week 10 or 11, depending on, again, how things go. The first exam is generally considered to be fairly difficult. The second exam is considered to be much less so, and most people get high B's, low A's on the second exam. So I don't, and I'll get it, and when we get closer to the exams, I'll explain this, but I don't do proctorio or any of that. I find such technology intrusive, and I haven't really had the need to assume that students are cheating from the very first, before they walk into the room. But like these exams will be completely open note, open book, open Stack Overflow. The key here being that you can look on Stack Overflow, but you can't post questions. That's kind of the dividing line. Any questions so far? Let's see. Do I have it? We have a chat, so please utilize that chat if you have questions. Or so far. Are the quizzes timed? I haven't really decided that they would be timed or not, but typically they take about 10 minutes. They would take about 10 to 15 minutes in class. So I don't really see a need to time them. I think there is a late penalty for them, but that applies towards turning them in. So, turn them in before that due date. Similarly, there is a late, the exams have a 2-hour limit on them, but there's a late, the way the exam late penalty works is that you have a 0.1% per minute deduction. In English, that means if you turn in your exam an hour late, it's only 6 points off. If you and this is just simply because when you're coding in an environment like this, you might suddenly experience a power outage or something. So George asks, can we use our IDEs or will we use code in a text box like 1068? The answer is both. Your answers will be submitted in a text box. However, you can do whatever you want on your computer. You're just, when you're done with your code, you can just copy paste that into the text box, right, on Canvas. Make sense? So you can code using whatever IDE you choose on the exam. Any tool that you have at your disposal, you can use other than other human beings actively communicating with you. Make sense? Okay. Recommended IDEs for Java. I highly recommend using either Eclipse or IntelliJ. I personally use IntelliJ. I find it very, 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 very useful. In fact, IntelliJ is what you currently see on my screen right now. But IntelliJ is much easier to show. So I'll show you how to do it from scratch in that case. So let's get started with our first assignment. Okay. Because for the most part, with it being flipped, that means that most of what you're going to be doing is going to be happening. You're going to be doing most of what your homework would normally be in class. So, yes, Laser. Well, I can't help you with the alphabet right now. I have to teach my class. Today is Laser's birthday. So also Laser is my son, short for Eliezer. Oh yeah, last thing before we Laser. Last thing before we before I get into the business portion of this. Hold on one second. He's decided to play with the light switch. Laser, I'm busy. Please don't play with the light switch. Okay? I'm sorry. I will help you after I'm done explaining to the class, okay? What's going to take so long? I know it's going to take so long. He is 4. So, you can come upstairs. So there will be some interruptions like that. I'm sorry. It's just the consequences of teaching from home. So let's see. So every Tuesday, which includes tonight, I will be holding what I call Distraction Discord. If you haven't joined the Discord channel yet, that's probably your best bet. Come over here, click on the link over here to join the Discord. That's just essentially a giant chat room. Every day, every Tuesday from 6 o'clock to 8 o'clock, I plan on streaming something, whatever I'm currently doing on my computer on Discord. So, yes, you can. So, that's just kind of a way to kind of, I think they're trying to say is build and engage with your community. But to be honest, it's a matter of hold on, I need to remove him from Laser. You have it upside down. Number one. Number two, I gotta take you downstairs because you were just all right, sorry about that. All right, so okay, so I'm sorry about that. I brought him down to Mama, who's currently showering. So, sorry about that. Okay, so back to business. So Discord. So use the Discord link. Join it. I'll be on there fairly frequently. If you have, we have various channels with various classes. So now let me show you how to get this set up here. Okay. So what you want to do is download the zip file for this assignment, which I've done so on my desktop over here, right? And then you'll want to unzip it, which I've already done. Well, let me go ahead and delete that because I've already moved them. Unzip, extract the code. You'll get a folder full of files. All right, so how do you do this in IntelliJ? It also works this way in Eclipse. Sorry, have to admit somebody into this room. Also works this way in Eclipse. So what you need to do is File, Project. So you want to start a new Java project, which you can see is automatically selected. Use whatever version's installed on your computer, hit Next. If you don't know how to install Java on your own computer, that's okay. I will show you. I have a separate video for that. But next, and I'll just call this Rabbit Hunt. Okay. And this window, there we go. Rabbit Hunt, SRC. So you'll see that it's created kind of a nice folder structure for us. Okay. I did choose light mode for my IntelliJ. The reason being is because light mode is better for those of us unfortunate to have astigmatism in their eyes. So, so what I'm going to do is I'm going to drag all these files. So there I've selected them all. I'm going to drag them. Notice where I'm dragging them. I'm dragging them here to SRC. To this SRC folder. Okay. Where I would be if it was doing that. Oh, did it? Come on. There we go. So drag it onto the SRC folder. And notice that it says move to specified files to directory. It's very important it goes in the SRC folder. It's actually like essential that it goes in the SRC folder, which stands for source. That's where IntelliJ will know where to look for your source code. Okay, everybody got that so far? So what we've got here is a working program. So let me go ahead and run the main file in IntelliJ. To run your file for the first time in IntelliJ, click, you can hit a keyboard shortcut to run, such as Shift F10 or Alt F10, but hit this arrow key. So you hit run. And we've got ourselves our program. So we'll start out blank like this. This is just simply because of an old feature from Java, but it's fine. Just hit run and it will start running. So this is our program, Fox and Rabbit. So we've got a grid. We've got walls. I'm going to stop this for a second. These are not Pac-Man walls where if you go off the edge of one, you suddenly go on the edge of the other. Oh yeah, it totally automatically compiles. It automatically compiles so long as the as everything is perfect, is running. Just as long as you don't have errors, it will automatically compile. And if it won't, and if you've got errors, it will yell at you. So anyway, we've got these walls and inside this grid. You've got these bushes. The role of them is that they block line of sight. This big red dot is the fox. This small brown dot is the rabbit. And the rabbit's objective is, the fox's objective is to not get eaten. Sorry, the fox's objective is to eat the rabbit. The rabbit's objective is not get eaten. So let's go ahead and reset it and run it again. Now, essentially what we've got is a small simulation. The moves are not synchronous. They take turns. So the fox moves and then the rabbit moves and then they alternate. There's a speed over here, which is kind of hard to see because of just how UI elements have changed over the years. But here at run, much slower now. And now we can also up it to be much faster. Fox eats the rabbit after 19 turns. So again, fox's objective, eat the rabbit. Rabbit's objective is survive 100 turns. Your goal is to make it so that the rabbit survives as often as possible. Your grade is as follows. Out of 100 points for rabbit survival, the way it works is that we have this other main program called grader over here. You run grader and it will tell you what your grade is. Now the rabbit has survived one time out of 300 or 0% of the time. So your score is accordingly a 0. The way it works is that we apply what's called a square root curve. Now the square root curve works like this. We take the survival rate, such as say your survival rate is 64%. Okay, take the square root of that, which is 8. Square root of 64 is 8. Multiply your whatever your square root was by 10. So 60 square root of 64 is equal to 8. 8 times 10 is 80. That is your grade for your survival rate. So 64% gets you a B. 81% survival rate will get you a 90 or an A on that. Right, the rabbit survives if it makes it 100 turns. Right, so let's just talk. So let's go ahead and see what's going on here. So let's go ahead and see this rabbit code, see what makes it tick and why it's doing an awful job of surviving. That being why it's doing an awful job of surviving. So we can see that it's got a constructor here. Okay, don't know precisely how that works. Okay. But decide move, I guess that's how it figures out how it's going to move. Right, it's totally how it figures out how it's going to move. It says return random, okay? Random model.min direction, model.max direction. Don't really know what those are precisely yet. You will in about 5 minutes. But it's pretty easy to intuit that we're just telling the rabbit to make a random move, which does not seem very good for survival. right? Let's take a look at the Fox code instead. Oh, it's got a lot more variables in there, 5 in fact. It's got its constructor, and it's got a decide move with some comments on it. Now, one thing I need to warn you, I highly recommend against copying the Fox code into the Rabbit and then trying to like reverse engineer it or like reverse whatever the decisions are. The Fox is a predator. Its code therefore is a lot more complex than Rabbit needs to be. In fact, the Rabbit code, you can get into a 90% survival rate with very, very, very simple code. So let's talk about what your objective is. There's really only one rule. You're only allowed to modify 2 classes. And in the first class you're allowed to modify is Rabbit. You can do anything you want to modify Rabbit. You can do whatever you want in Rabbit. As long as it's in Rabbit, it's fair game. You can modify this one as much as you want. The other one is Grader. You're allowed to change how many trials you're running to increase because this is luck based, you can increase it so there's less the number of trials, so there's less variability. But other than that, can't really change anything else in the grader. Okay, so so you can change anything in Rabbit and this line in the grader. So now what is all this other code? So this uses a model view controller. Did you happen to learn that in 1068 about model view controller paradigm? Okay, that is perfectly fine. Model view controller is now, if you've noticed, we're working with a GUI here, but I haven't said you have to modify any of the GUI elements, which you don't. You don't really have to. Notice that we ran the grader, that there was no GUI element whatsoever. We just ran it and it did standard system.out. The view, the GUI is just simply for you to, well, it's just to help you visualize what's going on in this simulation, right? So this is here to help you visualize what's going on. So the way the model view and controller works is that your program is split up into 3 parts. You've got the controller is fairly easy to understand what that is. That's anything that's button related, pretty much. Anything that affects that you hit and it affects the way the GUI runs, such as the speed, whether to stop it, run a single step, or hit the run button again. Oh, what did the Fox do there? Well, I'll explain that in a second, but that's what it is. What we're seeing over here, by the way, inside this window is what we call the view. Basically, what user elements we see in this program. Okay. The model is what you're kind of working on, which is the internal logic of the program, the things that will be interpreted by the view. So, so for the most part, again, you don't really need to look at anything but the animal code. I don't need the decompiler. You want to go into SRC over here to your source, and you can look in animal. And because remember, the Rabbit is an animal, so it has access to all the functions that that an animal has. So we've got the random function, as we see, which just simply chooses a random number. It has look, finds the first thing in a given direction. Distance, how far something is in a direction. I'll explain that in a bit more detail. Can move, and decide move. Now let's look at model and see what that has for us. It has a bunch of static variables in here. How many rows, how many columns there are. Numbers to correspond to north, northeast, southeast, southwest, west, and the like. There's also model.stay. So static final int stay. So for instance, if I change this into model.stay as opposed to model.random, run this. notice that the rabbit's just going to stay still at this point, and we will see what happens. So this is a losing proposition for a lot of times for the rabbit, just staying still, right? Because the fox is going to see him. How does fox see him? Well, let's look at the fox code for that. So the fox code, you don't want to copy it, but it will very much help us understand the way the things you can do with this program. Okay, so decide move. Can I see the rabbit? So first things, it sets up a variable. Can I see the rabbit now? Set it to false. So until I check around me, I don't know if I can see the rabbit currently. For loop for int I model.min direction. So model.min direction, that is north, right, to max direction, which is, well, actually, from your perspective, it would be clockwise to northwest. So each direction is a 45-degree turn. So that would be, so north, northeast, east, southeast, south, and so on and so forth. So it checks all the directions. Note the through. By the way, notice that it's an actual less than or equal to sign. That's okay. That's just simply my font doing weird things, or cool things rather. That's a less than or equal to sign. I have font ligatures enabled so that when I combine them, it looks like that. Okay, same over here with the fat equal sign. It's just two equal signs, but my fonts know to combine two equal signs into one big fat equal sign. So what we do is that we say, let's look at all these directions. If looking in a direction is equal to a rabbit. So what look does is says, given a direction, tell me what the first thing I see in that direction is. And there's four possible answers. The edge of the board, a bush, a fox, or a rabbit. So if I look in a direction and I see a rabbit, I see the rabbit. I've seen the rabbit. I set my direction. I set the direction that I've seen the rabbit in, and I set up the distance to the rabbit. So distance in a direction, that's just simply how far I've got to go until I hit something in that direction. So now, if I have seen the rabbit recently, right? Can see rabbit is equal to have seen rabbit. True. So if I have seen the rabbit, if the distance is greater than 0, distance to rabbit, so, you know, if I still have to get to the rabbit's last known position, subtract 1 and return the direction I want to go, which is towards the rabbit. Otherwise, well, if it's not greater than 0, it's equal to 0. I got to where the rabbit was. Where'd he go? Set the current, then I haven't seen it, and I set my current direction equal to a random direction. So what it does, if it doesn't see the rabbit, is that it paces back and forth, which is what this all this code does here. What this code simply does is says, hey, if I can move in the direction I want to go, if I can go wherever I'm trying, whatever direction I can, I do. Otherwise, if I can't, note these model.turns. Model.turn is super important. It says, model.turn says, hey, given a direction and a number, give me something that's in a similar, give me a direction that is relative to that. So, for instance, if I pass in north and 4, it's going to give me south instead. So what is this number? It is the number of 45-degree clockwise turns. So here is north 0 means nothing. North 1 gives me northeast. North 2 gives me east. North 3 gives me southeast. North 4 gives me south, and southwest for 5, and so on and so forth. This makes it so you don't have to have 8 blocks of code, 8 different blocks of code based on what direction you can currently see the fox in. So this just makes it all relative to one direction. So here it's saying, hey, if I've got an obstacle in front of me because I can't move this way, try to go around, and then try to go around this way. And if I can't, try to go around this way. And if I can't, choose a random direction. And you'll see that in the fox's code. So the rabbit strategy is, again, let's choose random. What I highly recommend doing for the rabbit is that there are two generalized strategies. The first is to exploit line of sight. And that's, I find, to be the easiest, by far the easiest strategy. Okay. So to exploit line of sight, this is the way it works, right? So let's stop. So let's go ahead and step. And you see the laser eyes that our fox friend shoots out, right? Notice that this vision is very much, even though is very much not the way real life vision works, right? So let's go ahead and grab a pen. Let's see, screen sharing. Do I have access to a pen if I am not the host? Apparently not. That is okay. That is okay. That is fine. So notice that basically that the fox is one row above the rabbit, but it can't see it. He's got to have a straight path to the rabbit in order to see it. So step, and now it can see it.
We'll do it in your
room. It does not, unless you have some way of, unless the program was constructed in a bit of an insecure way. Hi, Annie. Hello. So the way it's got to find it is by looking at by looking. But there's these big kind of things. You should only be able to move one step at a time. You should be able to move one step at a time. But if there's a bug in the program that enables you to teleport, then by all means exploit it. So, anyway, the point being is that if we do this, then oh, hold on. Whiteboard. So let's go ahead. Here I've got myself my fox. Okay. Just a horrible blob. There's my fox. So now here is the directions my fox can see. Right? Those are straight lines, despite my inability to see them, right? Note that basically we've got these giant cones that act as blind spots for this fox. So for instance, if the rabbit's over here, if our fluffy rabbit is over here, right? Now the turns are not simultaneous. So what's possible is that if the rabbit's just staying still, the fox moves, doesn't see the rabbit, moves into the spot where next turn it's going to be able to see the rabbit. Rabbit's turn, he looks around, sees the fox. Rabbit just moves right over here instead of being there, and now it's in a blind spot. Fox looks, can't see the rabbit, and he moves. So the first strategy, exploiting blind spots, very easy to do once you understand how to use model.turn and model. And the animal.look. It's very strong, very easy to get a very high grade with that. Okay, that's strategy number one. Strategy number two is, for those of you who know MMORPG terms, is kiting, which is where, now in MMORPGs, the strategy of kiting is where one player decides to take the aggro from an enemy, basically stick out their tongue, bite their thumb, and run away from the enemy. Essentially get the enemy annoyed enough at him to chase him, while the other players basically slowly whittle the enemy down. Or you do something like poison the enemy and run until the enemy's HP is depleted. So in this context, well, you and the fox move at the exact same rate. So there's no reason, so long as you don't crash and burn into something and you make your moves correctly, there's no reason why the fox should never be able to catch you. This is much harder to do, but much more satisfying when you pull it off, I feel. So, but it is much more difficult. Another thing you can do is also trap a fox in an infinite loop. If you, that's one possibility. If you trap it in an infinite loop by basically looping around bushes. So, now that being said, you're probably not going to get 100% survival rate for either of these strategies, because there's always the chance that you're in an unlucky situation. That the fox kind of just ambushes you before you have a chance to do anything. Okay, but the point being is that your code, if you use the first strategy, ends up being a lot simpler. Any last questions? I know I've droned on for a while on this, but I wanted to make sure that you got the full explanation since everybody was here. And feel free to unmute yourself to ask questions. So the second strategy is let the fox stay still until the fox finds you. And once the fox finds you, run away in an intelligent manner, such as like making laps around the board, or finding a bush, getting next to a bush, letting the fox find you, and then run around the bush with the fox right on your tail until the time expires. Believe it or not, avoiding line of sight is actually fairly straightforward and very easy. The first strategy is what I would recommend. What I recommend is by trying to have done by the end of class tomorrow is a very simple strategy. And if you can get it done today, great. Which is, and it's one that it can be improved on very easily. Which is by default, stay still. Return model.stay. And then if you see, look around each turn, look around for the fox. If you see the fox, move one space out of line of sight. Not in line of sight, so don't move away from the fox or towards the fox, but like move to the side or back and diagonal. Choose one of those directions, and you'll see that you'll get an immediate 30% survival rate or something like that, with just a for loop and one if statement. Once you have that, you have the tools to really expand and build up to something that gets like an 89% survival rate. All right. So, other questions? All right, couple things I want to note for this one. Also, Olivia, great to see you again. I'm very happy you were able to get into my class. So just wanted to say that.
Hi.
Hi.
I'm thrilled.
I do remember my students. So
I built my whole schedule around this class too. So
I feel flattered. So now, with regards to this, to working together on this one, I highly encourage collaboration. In my syllabus, which I will go over tomorrow, I have very clear clauses about what I find acceptable in terms of like letting other students see your code, which is that don't show other students your answers, but if you want to but it's more than okay to post your code and say, help me fix this, please. Make sense? I've got some very clear examples of what that is. Now, but for this one, this is a very different scenario. This first one, you're allowed to work in pairs. You're allowed to submit the exact same code as your partner for this one. Other ones, you're allowed to work with other people, but you got to submit different code and demo the code by yourself. That is the last step for this one. So demoing, when you are done, in order to turn it in, two-part process, you submit it, and then you show it to us to get your actual grade. I will go into more detail about that tomorrow, but to finish this, you have to show it off. Okay. So feel free to join with another person. So let's see. Suhan, I already have a Discord server up and running. Feel free to join it. I will post the link in the chat. So copy. Let me go ahead and post the invite link. Here's the invite link. Feel free to join it. I have multiple channels set up for each class. I also have chat rooms set up, and I have voice channels set up for each of those if you want. Suhan, if you would be okay, if you could open up breakout rooms and let students select their own breakout rooms, that'd be great.
Okay, let me try.
Mm-hmm.
Meanwhile, should I go to my link and draw my section, or just work here?
I don't know. What do people think? I've got 42 students here. Would people prefer to split up into their respective sessions or just simply stay in this one? Because I feel like since we're already here, it makes sense to stay in this one.
Yeah, it's fine. Just Suhan, make me a co-host so I can join rooms.
Yeah. So go ahead. So,
but I have a question.
Mm-hmm.
I need to kind of like create 40 breakout rooms.
No, you just need to create like I would create like 10 for this many students. 10 breakout rooms.
Oh, so that she could do the cooperations.
Yep. So create 10 breakout rooms and let the students join their own breakout rooms. Right? They let them choose once you open them up. That also allows us to jump in from one room to another and answer any questions individually. Right? All right. So the breakout rooms have been open. If you have someone you want to work with, communicate with them and join a room. Otherwise, play roulette and join a random room. I'll be around in a bit. I want to make sure that that my downstairs is still intact and then I'll be back. Last note, I won't be in most of the labs, but I will be here for this one at least. All right, I'm back. I'm just trying to find the installing Java video that I have. Suhan,
Yeah.
go ahead and try. So what I would recommend doing is jumping in and out of
A specific room.
the breakout rooms and just seeing if anybody needs help. So
Okay. Let me try to find the room with more of my students.
okay. Okay, all courses.
Like,
Right.
and that's all. But I think
so a test would be pretty easy to implement.
Yeah, just use the can move method and check in which direction you're able to move, and that's all.
Gotcha. Okay.
Very simple. Yeah, I just wanted to say, if you need any help, just go to the breakout room section. I mean, yeah, and you'll see ask for help button. And when you press that, I should be able to see your Suhan professor.
All right. So if you need Java, by the way, I'm pasting a link in chat. Open. And that is an open source version of Java. Just simply because the Oracle licensing on the other one is kind of So it's a long story, but Oracle's a terrible company. So it's very easy to just simply install that. And then I have a video on setting up IntelliJ once you have Java installed. Here's that video on installing IntelliJ. Since I got asked.
Specific question.
Uh-huh.
I have the OpenJDK installed through Homebrew on my Mac. Do you happen to know if that's an open source version or if that's an Oracle?
If it's OpenJDK, it's open source.
Cool.
So that's my assumption at least. So but I would assume that basically if it's coming, if you use Homebrew, which was what, and that means you installed it with like brew install OpenJDK or something?
Yeah, something like that.
Then it's probably open source.
Cool.
Mm-hmm. Yeah, normally I work in Linux, but ever since I've started playing with VR, and music, I've stayed in Windows. I spent way too much money on music software this Black Friday.
Let me guess, Ableton and some DSPs and whatnot?
Ableton,
or maybe FL?
I already owned FL Studio, so actually I spent about $500 purchasing the BBC Orchestra from Spitfire. So
oh, nice.
I found that that with regard to Linux, there's no issues on just using Linux as your normal daily driver on a computer in terms of working with classes and stuff. But yeah, all the computers here run Windows unless they're specifically Mac computers. What do you mean they don't allow it in the dorm?
The way they verify your computer, you have to download a piece of software, and there's no way to get it working on Linux. So you can't verify your computer to be allowed to use the network. I tried Wine. Well, I haven't tried all Wines. I guess I could use staging or something, but...
Have you tried and dual booting doesn't work?
Nah, it's based on the loaded system that they check.
Oh,
so...
That's rather
yeah.
silly. That seems rather silly. Well, Windows subsystem for Linux has managed to work for all the cases I needed.
That's what I use now.
Okay. So. All right, I'm going to jump to another room and see what people. But does anybody have specific questions before I jump?
There was a question about the bushes. I don't know who asked it.
You cannot occupy the same space, the same space as a bush.
No, it was basically like if you're in one space and then there's bushes directly in front and to your side, can you move diagonally?
Yes, you can move diagonally.
Okay.
You can also see diagonally, I would think.
Yes.
Okay.
Yeah, it's hex based. So. Or sorry, it's not hex based. It's it's like a queen. It's like a king in chess.
Re-implement the whole thing in hex grid.
Yeah, that'd be better. Is the lowercase model in the code referring to this specific model? Yes. So uppercase generally refers to class name in Java, like what type it is, and a lowercase is an instance variable. So model means the specific model of what we are currently playing right now. So George, you have it completely right. Okay.